Hello and welcome to yet another interesting conversation with interesting people from software development. I'm Bolboaca and I'm coming to you from Mozaic Works studios. And my guest today has a long history of challenging ideas in software development, particularly figuring out how we can change inside organizations, how we can change our environment around us. And I'm really interested in talking to her and really excited to talk to Linda Rising. Welcome, Linda.
Thank you so much for inviting me. It's a pleasure to be here.
So I like to ask, my first question is how you got into programming. What drove you to join this domain?
Oh, maybe we don't want to go back that far. I just had a significant birthday. I'm now 79. So when I talk about starting in programming, we have to go back to 1981, which seems like a long time ago, but I was 40 years old. I didn't grow up with a computer. I didn't grow up programming like a lot of children today. In fact, no one did at the time. No one had computers. I started out as a chemist, and then I became a mathematician. And it was only later in life that I discovered programming. And it was a series of accidents that led me to see the joy of creating programs and being involved as a programmer. So 1981, a long time ago.
It's still very interesting because when we look at programming today, what we see in the landscape is a lot of people who go through programming universities and learn programming there or go through specialized programming courses. So I still think it's quite interesting to understand how a background in sciences, in mathematics and so on influences your approach to programming, because that is something we don't see a lot in today.
Yes, I agree. And I think perhaps I had an advantage because of that background, especially the background in mathematics. If you've ever taken any graduate courses in mathematics, you know that the goal is to write a proof. And there's a very similar process involved in creating a program, because you're trying to solve a problem of some kind, and the problem involves a series of steps. But the steps that your brain goes through in solving the problem is very different from what you actually create as the solution. And for me, in my long experience of seeing how other people program, I'm not sure they understand that. I think they believe that programming is writing down what the steps are that their brain is taking. And that's not what programming is about. Programming is about writing the solution to the problem in the most elegant. That's a word from mathematics we used all the time. Elegant. I don't see too many elegant programs. What I see is a capture of the way the problem was solved, the steps that were used, the process in solving instead of the elegant solution. So because I had an understanding of that, I think from the beginning I was a better programmer in a sense.
I know there's a long discussion about elegance in mathematics and in science, and somehow elegance in mathematics seems to be very related to to the soundness of the theories, let's say, more or less. How do you define elegance in mathematics and how it relates to programming?
I think that if you've never seen And that's maybe what we're missing. If you've never seen an elegant program or an elegant proof in mathematics, then perhaps it's harder for you to understand it. I think the people in the patterns community were trying to achieve elegance when they talked about the quality without a name, what Alexander meant by those qualities in architecture that speak to us, where we feel like this is a good place. I feel at home there. I can remember the first time I looked at a large program, a program that was really too big to understand. And yet I felt I could find my way around in it. That sense that if I were in a big house, I would know where to go for the kitchen, or this is obviously a closet, or the bedroom is over here, that you feel at home, even in this large structure. The first time I had a sense of that, I thought that's maybe a little bit of what elegance is that it's so intuitive, it's so well designed that it makes me feel at home. And I didn't have to struggle to understand that very large program. I did have to sit on the floor. My boss came over when I was working on that and he said, Linda, what's wrong? Why aren't you sitting at your desk? I said, no, this program is so big that I need to put all of the modules in different places so that I can go where I need to go. But I knew how to do that. The program was designed so that I could find my way around in it easily. That is a part of elegance.
So I think that's a very interesting point because my impression from reading history about software development is that in the 70s and around the 80s, that's the point when we started to get larger and larger programs. And that's when we actually ended up with a problem because we didn't know how to organize these programs in a way that allowed us to actually change them later or do something like that. And it still seems an unsolved problem in the industry as a whole.
Yes, I agree with you. And I think the transition was made because people moved. I mean, I spent some time writing assembler code and teaching a class in assembler. And if you've ever written in assembler language, you know there are no pieces, there are no modules, let alone objects, which wasn't to come until much later. So how do you structure it? And the answer is you don't. You just write a long sequence of statements, and every now and then you insert go to, and now you run off to another piece, and then you come back, and trying to understand the flow of the argument, the design of the system is almost impossible. So when we made that transition to design, that there should be a design, I'm not sure that we did it right. I think we tried to do it intuitively. I think we tried to do it without really understanding the entire system, so there was no architecture. And what we wound up with was kind of warmed over assembler where we still had a hard time understanding the system as a whole and where those various pieces are. And I agree, there are lots of large systems out there that are still running. NASA, banks, insurance companies, enormous programs that are still written that way where no one alive understands what that program does. It's a little scary.
Yeah, I have seen this, and I have heard many stories about this. I have also worked with a few teams who didn't know anymore what was in their code. So it was,
Yes.
yeah, it's very. So I realized at one point that perhaps one of the challenges that we have is that we write code in text files, and it's fundamentally linear. And this limits our perception and trains our perception to linearity. So we cannot see any more moving parts or dynamics of the system. Or have you noticed that? Do you think it?
Yes. Yeah. And I would add even further, I have a PhD in computer science, and part of the research was around trying to measure what elegance is, to determine in a more exact way what is good design. And along the way, I measured a lot of variables. And what you begin to see is there's a human limit on complexity. I don't know if you're familiar with the work of George Miller, who wrote a paper in the 80s called 7 plus or minus 2. And we think that that's the limit on the understanding of complexity. But what I found is that I think it's smaller than that. I think it's between 4 and 6. So when I was measuring the design of a program, if I saw more than 6 variables, parameters, little pieces, any more than 6, that meant that that part of the system was going to have problems. And you could see that. You could see more errors. You could see more maintenance over time, more changes within that module. The number 6 was almost like a flag that said, we can't understand this well enough. And so it's always going to cause problems. I have measured it, and it is real.
I'm wondering if this has a connection with the number of chunks that you can have in memory, in human memory, because it seems to be very similar. So it seems that we can work with like 7 concepts at a time. And then they kind of chunk together, and you can go at a higher level of abstraction and work with other 7 things that are.
I think that's exactly right, that we have that limit in short-term memory, and we can only think about and work with that very small number. But if you organize it differently, that does allow you to move up a level in complexity, because now you can think of one entire section of the system as a single thing. And that is good design. Good design will allow you to move around the system that way by giving you the chance to say, this piece over here, you can just ignore it. It is a thing. And now we can include other things along with it and move up a level of abstraction. The problem is most systems aren't designed that way. They're so interconnected, the pieces overlap, the connections are so strong that it's very difficult to isolate one part of the system and say, that is a thing. We don't have to worry about it. We can just say, that's a thing, and now I can concentrate on other things. If a system allows you to do that, then I say it's well designed, it's approaching elegance.
However, there seems to be a counterpart to it, in the sense that abstractions also have a cost in understanding them. So it's not enough to abstract away. You have to find the right abstractions, more or less.
Yes, absolutely. And there are always trade-offs. So the trade-off for having that higher level of abstraction is that perhaps you don't spend the time to really understand what's going on in that thing, and now you make assumptions. Oh, I understand it, even though you don't. And you never get down to dig into those details. My husband was also a developer, and he said that what happened over time, they could see it in younger and younger programmers, is they didn't understand what was going on in the operating system and in the machine itself, and they would make assumptions. Oh, I know what's going on when I say sine, cosine, add, subtract, multiply, and divide. So I understand the behavior of those operations when they really didn't. So if we don't have the details, if we don't really understand those details, then we can make assumptions as we move up, and those assumptions could be wrong.
Yeah, or you could design, I mean, one example that I keep giving is how the initial Java standard library was designed, which is kind of a display of all the design patterns that the people knew. And in order to open a file, I think it's solved now, but in order to open a file, you needed to use like 5 different classes.
Well, you know, programmers have always been very smart people, and they love puzzles, and they love to, well, show off how smart they are. And the goal pretty much has always been, I'll bet you can't figure out what this does. Look at this line of code. There was a programming language called APL where you could write an enormous amount in one sentence. And I can remember people running around saying, I'll bet you can't guess what this does. The same was true in C long before C++. C was arcane and it was condensed, and programmers loved that because now they could show how smart they were. And they were. These are very smart people. So it has always been a characteristic of people who write code that, well, this is a chance to show how smart I am, how many patterns I know, how well I understand this language. Yes, that is an important element. It's always been there.
So you're mentioning that you're working in assembler and in this, but at some point you got also familiarized with object-oriented programming, and I'm curious, was this a step ahead? What prompted you to look at object-oriented and say, this is useful?
Well, there was an intermediate step, which was the time I spent with the programming language Ada. Ada is not object oriented, it is object based. And I had the chance to work on the largest Ada project in the world. It was involved in a strategic weapons system at Magnavox. So yes, I have written code for weapons, sorry. And I loved it. That is still my favorite language. So later, when I discovered the design patterns in 1994, that was for me the transition. Because the design patterns book that came out in 1994 was about object-oriented programming languages. Now, I knew some object-oriented programming languages, but I wasn't as familiar with them. So in order to really understand, and I'm going to use another word here, which is sell, to sell other people on the idea of using design patterns to convince them, to influence them that this was a good idea, then I had to move away from Ada and to move into the more object-oriented space. So that was 1994. That's a long time ago. I'm not sure I even remember any object-oriented programming languages. It was mostly C++. At the time, the company I was working for had a lot of very small projects in C++, and we were all, well, learning that together, learning how to make the transition from the large switch, which we were writing in that company, which was in a funny version of Pascal, to make the transition to object-oriented programming.
And I know you told a story at one point that you joined the conference and there was a queue, and the queue was actually to the book of
Yes.
design patterns. And to me, this is something that's very weird, because when I first learned about the Genga 4 design patterns, these were widely established. It seemed like it's the norm. It's part of the industry. What do you think
Yeah.
was the novelty in it? Or
Well, I think that when we talked about elegance earlier, if someone has ever seen an elegant program, they understand it. They may not be able to write it themselves or define it clearly, but they know it, they get it. And I think the same thing happened with the design patterns. When those four authors presented that tutorial at Uppsala in 1994, everyone in the audience, and it was a big room just full of people, everyone looked at those and said, there is something there. I get that. I understand it. I can see how valuable that would be to have the notion of, say, a mediator. I see what a mediator is. I've used it. I've written it, but now I know I can say the word mediator, and now I mean something to everyone who speaks this language, and how powerful that would be. This is a move up in abstraction that suddenly appealed to everyone. That now we can draw a whole system on a blackboard by saying, a mediator will talk to a factory and a visitor will come around and we'll have proxies at the interface. And yes, yes. And the power of that was immediately apparent to anybody who'd ever written any code at all. And they saw that not only could we start with these 23 patterns, there are probably a lot more. Maybe I could even write one. And that's how it started.
yeah, and we'll come back to this. But another thing that I find interesting due to your experience, do you have in mathematics like big proofs, like we have big programs in in software?
Yes. Oh, yeah. They're not as big, but the bigness or the size is in the spaces between the steps. So I had an advisor when I was working on my PhD in mathematics. I had an advisor who would get to a certain point and then he would say, well, now, Linda, fill in the details. He knew what the next step was. He could go from one step to another, but in between, in that space, was a huge amount of detail that really needed to be filled in for most people to really understand what he was talking about. He could make the leap. He understood, but most people couldn't. So it was a little bit like a subroutine in a language like Fortran or C, that now that little piece, somebody else has to fill that in before we could get a paper published that would outline this. And that can be as detailed as you want, and that can grow. So the more detail, the bigger it is. When really, maybe the entire proof could have been done in, say, 4 steps. But by the time you publish it, it's going to be 10 pages of explanation and other theory and other details that have to be added. It could probably grow forever till you get down to the axioms and postulates that everybody would understand. So, yeah, there's an analogy, absolutely.
And I think it's also an analogy in the sense that parts of the proof tend to be abstracted away at some points, right?
Yes, yes, and they could be wrong.
Mm.
There could be human error, just as there is human error in a program. We forget to test some little piece of it, and we made an assumption that that little piece was going to have a certain behavior. You can do exactly the same thing in mathematics. We assume that going from one step to another is going to lead us in a certain direction when we were wrong. And that has happened so many times, even in published papers where the steps were too big and the assumptions were flawed. And so the end result turned out to be not true.
Mm-hmm. And you mentioned test, which is another part of programming that I'm very curious to hear your opinion about, since you come from mathematics, which tends to work from science, which tends to be much more structured and with much more tests. When were you first subjected to the idea of automated tests in software, and what did you think about those?
Well, if you're writing a very large program, and that was my experience in the beginning, then that program is probably too big for any one developer to test. It may even be too big for any one programmer to compile. You may have to hand your code over to a committee, and that committee will put all of those pieces together and compile it. And that committee then will also have to hand it over to a system test. And that committee, that group of people will test it. So I saw that from the beginning, that I would write my code and I would have no idea. I wouldn't know whether it really did what I thought it was going to do. I sometimes wouldn't know for months. I worked on the 777 airplane, and I wrote a piece that was involved in ground to air communication that sits in the cockpit. And we could not test that until we had a simulator. And I can remember to this day standing in a conference room watching a simulator for the first time, months after I had written that code, watching messages go back and forth. And I cried. I was so happy because I had no way of knowing. And it was at that moment I realized that without testing, we have no assurance, even if we've been so careful, even if you've had good code reviews, which we did, until you actually run it on a simulator or a prototype or on an actual machine or in an airplane, you don't know whether this really does what you think it does or not. It's essential, that testing component.
And how about the idea of test-driven development or test-first programming, where you start with the tests instead of starting with the code, especially for people who have, this is something I noticed, people who have training in abstract domains. They are very good at figuring out the abstractions beforehand, and then switching to something like test-driven development can be quite difficult because it's thinking the other way around in a way.
Yeah. I think there's a time and a place for that. I have never been a fan of it, but maybe that's because my background has always been in large systems. And I can remember talking to Kent Beck and Martin Fowler and a whole host of other people about that approach, saying, have you ever worked on a system that was so large that you couldn't, as an individual developer, that you couldn't compile it or test it? And they never had. So if you've ever worked on a really large system, then you know the limitations of that test first development, of thinking in terms of, well, here's a test that will fail and now that will drive my code, how that just would not work. It could be maybe adapted. I'm not sure. But I think there are a lot of things in the Agile toolbox that really only work well for what I would call relatively small, easy, or easier programs. If you're writing the flight management system for the 777 airplane and you want to write a test, well, what would that be? I have no idea.
So we've actually had a talk at one of our conferences, at ITACON conference, with someone who works as a pilot and is testing simulators fundamentally. And they need
Yes.
to sign that the simulator is precisely like the actual plane. And that signature
Yes.
is enforceable in court for like 10 years. So if you fail that, and it's interesting that they are writing tests, but he was pointing out that some of the tests are very weird because you can say things like I don't remember the precise test, but it was something like, okay, you can assume that the plane is flying normally, but if it's flying upside down, then the test suddenly changed. So you need to be very
That's
careful
right.
on the context
Yes.
and so on.
Yes.
Uh,
Yes.
we will link this
So,
talk for people interested, but it shows that you can do it, but it's also not not as easy as it may look for other systems.
yes. Yeah,
Now,
and that's not to say that the agile approaches have not been valuable, because certainly I know the overhead that was involved both on the 777 and on all of the military systems I used. There was so much overhead, and it was there for a reason, because these are fault tolerant systems that involve security. You don't want software flying an airplane if it hasn't been extensively tested. But I believe it could have been done better, and it could have been done in a more agile fashion. There wasn't really a requirement that we have all this heavy duty overhead, but I can see the reason for it, because lives are at stake. You want military software to do what it purports to do. You want the airplane to fly. Yes. So there's a lot of history there. Really hard to change.
yeah, of course. All right, and so you learned about design patterns, and that has put you on the path towards thinking about change patterns. What was in between these two? How you got to change patterns from design patterns?
Well, the Design Patterns book came out in 1994. And around that time, there was a conference that you know about. It's called PLoP,
Mhm.
because other people were interested in patterns, not just the Gang of Four, not just those four authors. They were also interested in looking at the work of Christopher Alexander, and the idea occurred to a couple of them that we should have a conference and we should all get together, those of us who are interested in patterns, and we should talk about patterns. Maybe some of us might want to write patterns. What's the process going to be for validating those patterns? How do we have our discussion about patterns? So there was a whole sort of a community of people who grew up around the notion, well, first of all, of design patterns. And for me, in going to those conferences, the question I was facing in my workplace was, how do you get people to use them? It's not enough just to write a book. And even though a lot of people did line up at Uppsala in 1994, a lot of people bought that book. But how do we know that they're using them? How do we get other people who might not know about the book? How do we tell them about it? What about other patterns besides the Gang of Four? What about using? How about encouraging people? And so another group of us, a subgroup of us, said, well, let's talk about patterns for getting other people to use patterns. That's how it started. Surely there are patterns there. And in the beginning, I thought they would be technical because I was a technical person. The patterns were technical. I thought the solutions would also be technical. And as you know, or you've probably heard me say, that changed my life because now I had to understand that people choose to use patterns or do any one of a number of things, not because of a technical advantage or because they look at evidence or because the facts would lead them in a certain direction, but for a whole host of other reasons that don't have anything to do with anything except for this person. It's about people. And I didn't know anything about people. I thought I did, but I was wrong. So I had to learn.
So many people don't realize that the book Fearless Change is actually a patterns book. And it came out of the
Yeah.
PLoP
And
community.
it took 10 years for me to write that book because I had to make a transition from being strictly technical, from being a programmer, from being someone who was interested in design patterns because they were a good technical thing, to understanding how people decide to do anything. I had an enormous amount of new domains to conquer, new ways of thinking. It totally changed how I do everything. So no wonder it took 10 years. Of course, the second book, More Fearless Change, that also took 10 years, but that was for a different reason.
Uh, so going back to this, when you're writing Fearless Change and you're studying for it, what was your biggest surprise in the way people react?
I think the same thing that's going on right now. We live in interesting times because now a vaccine is beginning to be available that would mean the difference between life and death. I have friends who have died in this pandemic. I have close friends, people who are no longer around because they had a severe reaction to the virus. They were older. It's the most at risk population. And when they contracted the virus, they died. So we know that in the United States alone, more than 500,000, more than 500,000 people have died. Yet, I know people in my circle, in my community, who say, I do not want to get the vaccine. They're not convinced by data. They're not convinced by the evidence. They're not even convinced by seeing or knowing someone who has died of the virus. Now, why won't they get the vaccine? A whole host of reasons. And it's different for every person. Some of them are afraid that the drug companies have not done a good job of testing. Some of them have heard a story about someone who died because they got the vaccine. Who knows? But it's an individual, it's a personal, it's an emotional reason, if we can even use that word. And for that reason, they say, I will not get vaccinated. And that's true for every decision we make. Facts do not convince. We think we are convinced by facts. We believe that. I still believe that. But the evidence shows no. So for me, that was the biggest revelation in how people think that we are not driven by data. None of us, even the most rational, the most logical, the most thoughtful person, that's not how we make decisions. And we never have in our long evolutionary history. We have never made rational decisions. It's all emotional and it's based on stuff we don't even know ourselves. It's a mystery. So now I teach classes in it and give talks about it, and I'm still learning.
I'm looking at some of the change cards that you have for fearless change, and actually one of them is this emotional connection. Connecting with the feelings of your audience is usually more effective in persuading them than just presenting facts.
Yes. Because if they trust you, if the person you're trying to influence believes that you are being honest with them, that you're telling them the truth as you see it, that you have their best interests at heart, that you care for them, that you know their struggles, the difficulties they're going through, then they're much more likely to listen to what you have to say about vaccines or design patterns or whatever it is. They'll be more open to listening to you. So emotional connection, that's a very good pattern. There are so many in there that have to do with that kind of, I guess, bridge between people that don't have anything to do with facts or evidence. It has to do with whether I trust you, whether I like you, whether I believe you. That's how we make decisions.
Yeah, related to that, I just browsed through, and one of them is brown bag.
Yes.
Which is another another one of those tricks when
brown
people
bag.
when people are eating, they tend to be more receptive to.
Yes. Oh, yes. There are so many interesting scientific experiments that show if people are eating together, then they are more likely to be influenced by what other people have to say. They do a better job of listening. They pay attention. They feel closer. There are a lot of languages where the word for friend has to do with food. Like French, the word is compagnon, someone with whom I break bread. And that has been our evolutionary history, that we only shared food with people we trusted, was our immediate family and our tribe. And we still have that. That evolutionary tendency is deeply hardwired in us, even though we now have food in the workplace and we have lunch with people we hardly know. There's still that connection. And so you can use that to say, let's have lunch together. Let's all eat together. And I will tell you some of these design patterns that I saw at Uppsala last week. And while we're eating, you're listening, you're paying attention, you're much more open to what I have to say.
And I also like another one that I found, which is champion skeptic. We often run away from people who are against our ideas or the change and so on. But I noticed this in my coaching activity, that I embrace the skeptics. I think they are wonderful because they tell me all the things that could go wrong with.
Yes. And the word we have to pay attention to is skeptic, because a skeptic is not a cynic. This is from the Greek. In early Greek culture, the skeptics were important because they asked really insightful questions. And that's what you want, is someone who will say, now have we thought about, or what about this? Or did we think about that? And those questions are there to make us think. Those questions are there to help us make a better decision, not just to attack us, not just to be negative. That's a cynic. A cynic is a professional negative person. A skeptic is curious, wants to know, needs more information, wants the group to do a good job, wants the company to make the right decision. That's a skeptic. And those people are valuable. Yes.
Yeah. And yet another one that I found here, involve everyone.
That was a surprise for me, because I can remember when I wrote that pattern, I thought we are talking to just the technical people, because at the time that's what I was. Those were the people I knew. And then we happened to have a meeting with all of the secretaries, and we were just talking. They said, well, what are these patterns? And we explained it to them. And they said, well, I think we know some of those patterns. Of course, they knew do food. They knew that one. Absolutely. And we were surprised that they knew most of these patterns. They knew champion skeptic. They knew guru on your side. They knew corporate angel, connector. Yeah. And they began to contribute. They began to write patterns. And all of a sudden, once those people were involved, they told everybody. So don't just focus on one group saying, oh, well, they're the only ones who could understand this new idea. Or if we're going to try to introduce vaccines, we don't have to worry about those people because we don't care about them. No, you need to bring everybody in. And as soon as you do that, it will make your job so much easier. Tell everybody.
So I'm curious now, looking at some of these patterns. They look very simple and nicely written, and especially when you see them on cards. But it took you 10 years to get to those, and I can see why. But I'm curious, what was your process? What were the hurdles?
So we had a series of workshops. We started at Uppsala. We had an Uppsala workshop where people would talk about experiences they had in introducing new ideas of any kind. And then we would write those down on cards and spread them out on a table. And then we would look for overlap. We would ask questions. And then we would say, all right, 2 or 3 people can work on this pattern, 2 or 3 people can work on that pattern. And we'll see if we can put together by the end of the day at least one pattern from a collection of people. And then the next day we would have a writer's workshop. You know what that is, where we sit in a circle and we make comments about the patterns. And then we would take those back and put them in we had a repository, a pattern repository. And then we would send it out. At that time, we had a listserv, a mailing list. Other people would then comment. Other people then contributed. It grew organically from a handful of workshops, and then other people began to contribute. There isn't any pattern in Fearless Change or More Fearless Change that hasn't been extensively reviewed. Everyone went to PLoP at least once. That's another reason why it took so long, is that we wanted to make sure if they were patterns that they had been validated by the experience of lots and lots and lots of other people at various levels, executives, developers, testers, secretaries, marketing guys, that lots of people with different backgrounds had all looked at it and had all said, yes, here's my take, here are my comments, here's what I would suggest, you can think about this. So it wasn't just Mary Lynn and I sat down and wrote a bunch of patterns. It took forever to get that done for every single pattern in both books.
It sounds a lot like quite a more scientific process, more kind of a discovery process with a lot of reviews and a lot of, right?
Yes, in science, you would call that peer review. Somebody is looking at your work and saying whether or not they buy into it, whether they agree with it, whether it matches their experience or not. We didn't have any way of testing it like you would test a computer program, but it was the next best thing to run it through the brains of a lot of other people to say, have you seen this? Have you used it? Do you believe it? Does it help you? Has anybody ever used it on you? Is there anything about this that we could make it better? Is there anything about it where you're not sure? Send us your comments, your suggestions. So that was our way of testing every single one of those patterns, all of them.
Now, I'm curious about one thing because uh, when we talk about teams and organizations, we've realized, well, recently, at least in the agile space, that we are talking about complex adaptive systems who fundamentally have are, let's say, unpredictable in a way, and they have emergence properties and so on. How does it happen that patterns actually apply to complex adaptive systems? Isn't this a weird thing?
Well, the only way you can change a complex adaptive system is to do a little test. It's called probe. Do some small thing and then watch. See what happens. That's called sense. Probe, sense. And then, based on what you saw from that small thing you did, now you can decide what the next small step will be. And that's really a set of fearless change patterns. We talk about that in the first part of fearless change. It's just do it. Just try something. Don't wait until you feel that you know everything about the organization or that you know everything about what you're trying to introduce. Just do some small thing and then stop. The pattern is called time for reflection. Stop. Think about it. What happened here? And now, based on what you see, take the next, and it's got to be so small. We call it baby steps. Just the next tiny, don't get carried away because it's a complex adaptive system. You don't know what will happen when you take the next step. So you've got to consciously make it as small as possible and then repeat that. Take the next baby step. Stop. Take time for reflection. And that's exactly what you do with a complex adaptive system. Probe, respond, probe, sense, respond. It's the only way forward. So when you talk to an executive and they want to make a timeline out for the next 6 months and they want to have a goal, we're going to all be agile by June. You say, that's nonsense. You cannot plan it. You don't know what's going to happen. And in fact, what we may do by taking action is move backwards. We could make things worse. We don't know. So the only way forward is, yes, it's good to have a goal, but it's to take little steps and then stop, watch, see what happens, and then take the next step. That's how we as scientists, as baby scientists, that's how we learn to walk. That's how we learn to talk. Try something, see what happens. What do people around us do when we say blah, 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 blah? That's how we learn to talk. We didn't go to class to learn English or French or German or Russian or whatever your language is. No, as babies, we just tried something. We thought we heard our mothers say, well, 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 well. And then so we say that, well, 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 well. It was just a little thing. And then we looked to see what people did. And then we tried something else. And we were being very scientific. working with a complex adaptive system. So we should watch babies. They know how to do it.
We should probably let babies do changes in organizations rather
Yes,
than
yes,
executives.
yes. Put the babies in charge. Yeah.
But when you have, um, I understand this, and this is precisely what we explain a lot to executives, and because often they ask us, so we want a plan for becoming agile, and we want the steps and all that, uh, and it's like no, it doesn't work like that. But I think there's also another component where you can work, which is constraints, setting constraints on the system. And I'm not sure if
Sure.
you covered this. This is something interesting.
Yeah, and of course, I would never tell an executive that that won't work. I would never do that. And I would also not, executives have sort of a collection of things that they use, their set of operations. I would never destroy that. I would find a way to fit in this approach to what they have and just ever so slowly and very gently kind of lead them to see what was going on. I wouldn't lie to them and I wouldn't tell them something that wasn't true, but I also wouldn't destroy what they need to make their plan or to make their decision. They have to have that. And so, and you know that already. We just want to make sure that our listeners know that. You don't ever tell an executive, oh, that's ridiculous, that wouldn't work. You try to adapt to them, and now you fit in your little experiments within their plan, with their goals. You try to make them look good. There are a whole host of patterns here that are involved in working with executives. But yeah, now I forgot your question, which was about constraints.
Yes.
Yes, yes, absolutely. That's an important piece of it. And I think executives understand that, especially now. I mean, if this past year has been about anything, it has been about constraints, what we can't do, what we'd like to do, but we can't. And in fact, if you remember the population of adoption from E.M. Rogers, right now we are all laggards. We want to go back to the way it was. And we all feel that. So this is good. When we become able to do more, I hate to use the word normal, but when normal, whatever that is, comes back, let's not forget how we felt. We didn't like this change. So when we work with people who are unhappy about change, let's remember that we all felt that way. We were all laggards. We want to go back to the way it was. That's the definition of a laggard. But we can't. That's the severe constraint. So this past year has all been about being a laggard and facing a severe, overwhelming, really, constraint.
And so we talked about, let's say, the strategic component to change, which is more on the executive level. But then these patterns can also be applied. Let's say if I'm a developer in a team and I want to change something around my team, maybe adopt design patterns or try a different technology or whatever else I would be interested in. But you mentioned though that it took you a lot of a big change in mindset to figure out these these change patterns. Um, so do you think it would be very difficult for people who are in a development team, for example, to adopt these and to change?
I think that anybody can use any of the patterns, and that would be a good way to start. That I have a lot of sympathy for developers because most of them only have technical backgrounds. And that's exactly where I was when I started writing the patterns. That was me. I had a technical background. I didn't understand how people made decisions. I didn't understand what would influence people. In fact, now I teach classes in those specifically aimed at technical people because I can identify with that. I know how they feel. But every developer understands do food. They all know that. They know that, yes, if I bring in chocolate chip cookies or a nice cake or some special treat, everybody's happier. They know that. They feel that. And so, yes, it makes sense that if I want to talk about my idea, that if I bring in some cookies, I'm probably going to have a better time of it and people are going to be more receptive and they're going to listen. They get that. So there are a lot of those patterns that are so intuitive and, as you said, so simple. This doesn't take a lot to understand that anybody can do a better job than just getting up and making a PowerPoint presentation full of cost benefit analysis and a list of facts. Everybody understands that that doesn't work because we've all tried it and we've known it wasn't very successful. So what else can we do? So they can just grab a few of those patterns and get started.
And as you mentioned, just try one of them, and if it doesn't work, that's still fine.
Yes, yeah, exactly. I have a class I teach on influence strategies. A lot of evidence and research behind those strategies, but sometimes people don't like one of the strategies or another one. And I always say, if you don't like this one, don't use it. If it makes you feel uncomfortable and you say, that's not me, I don't think I can do that, well, that's fine. Don't do it. Don't use it. Only adopt the ones that you feel fit with who you are, that you're comfortable using. Because if you don't, other people know. They pick up that you're just doing this to influence them. And that means you're not going to be successful. So if it works to bring in chocolate chip cookies, do it. If it doesn't work for you to bring in chocolate chip cookies, then don't do it. So you find the patterns where you can pick up that card and say, yes, I can do that. I can do that one.
And this leads to, let's say, a more cynical view that you might have on that one might have on patterns, which is these are meant to manipulate people, to push them into doing things they don't really want to do.
Well, in a way they are, because they might not have made the decision. Let's take design patterns. They might not ever have read the book. They might not ever have adopted mediator or visitor or factory method. They might not have. If you hadn't influenced them, if you hadn't introduced them to agile development or test first development, they might not ever have gone down that path. So yes, you are influencing them. You are moving them in a direction they might not have gone. The difference here is ethics. Robert Cialdini wrote the book on influence, and he's very careful to say, you must stick with the truth. You must not lie. You must not deceive. So if you're telling people things that are good, that will help them, this will help you in your job, this will help you in your life, then okay, let's use those influence strategies. It is not ethical if what you're doing is going to hurt them or be a bad decision for them in the long run. That's not ethical. But if it's an ethical path, then by all means, let's show them a better way.
Yeah.
That should be what it's all about, is let's show them a better way.
All right. So I'd like to ask you, because I think many people who are watching this are not familiar with what the PLoP communities are doing. And even for me, it was a big surprise when I met Rebecca in Porto many years ago to find out that this is one of the oldest communities, I think, in software development, and with such a strong history and long history. What happens now in the PLoP communities, and what do you find interesting? Because you are there a lot, I think.
The PLoP community is still meeting once a year, and the intent is still the same, which is to examine patterns, talk about patterns, look at the future of patterns. We have been meeting since 1994, which is the same year the Gang of Four book came out. It's a very small group of people. It has changed over time. And we gather in small groups. And the primary activity is what's called a writer's workshop, where we look at patterns that other people have written and we give feedback according to a pretty strict process that we learned in the very beginning from Dick Gabriel, who said, this is what real writers do at real writers' workshops, people who write novels and poetry. And that's what we're doing. We are writing, so maybe we should use these techniques as well. So it's been going on since 1994, so that's a long time. And it often piggybacks on another conference like Uppsala, or Uppsala is no longer around. Sometimes it piggybacks on an Agile conference or a testing conference or a programming language conference, or sometimes it is a standalone small conference. So that's basically it. It's a wonderful group of people who care about making the world a better place.
Yeah, and I can attest to that the level of conversations in the PLoP meetings is very, very high. And I've learned many things that prompted me to research more things.
Good.
The latest one, I think, being the concept of stasis, and it's a lot of interesting ideas. Yes. I like to this was an amazing conversation, and it's been really nice. But it's time to move to close, and I think we have a few questions that we end up with. First question is, what book did you like and would recommend to our audience?
So when I get asked that question, I always have to say, well, of course, the book I recommend is Fearless Change, or More Fearless Change, but I'm not going to do that. The book that everybody should read, but nobody has time for, is Daniel Kahneman's book, Thinking Fast and Slow. So Daniel Kahneman won the Nobel Prize in 2002. Even though he's a psychologist, he won the prize for economic sciences. And that book should change how we think about thinking. It's full of science. It's one chapter after another with evidence that shows how we think. Now, having said that, I know most people have heard of the book. Sometimes they bought the book. Sometimes they read the first chapter of the book, but then they gave up. It's a very difficult book to read. It's a big, heavy, dense book. So I finally started giving a talk. So if you just go to YouTube and search on Linda Rising, Thinking Fast and Slow, that will give you a little bit of an introduction to the book, and then maybe you can read the book. But it changed forever how I think about thinking. And that's what we all do for a living. That's how we get through the day. We are thinkers.
Yeah, and I've actually read the book, and it is very, very
Good.
interesting. It is highly recommended. I understand why it might look scary because it is a long book, but it is very, very interesting. What book you did not like and would not recommend?
Oh, ah, I, do I have to answer that?
Only if you want to. None of the questions are mandatory, of course.
Okay. Because sometimes it's just personal opinion that I'm going to just say a category without calling out a specific book. So a category of book that I don't like is a book that tries to make a recommendation or a suggestion without any evidence. And there are a lot of books out there, both technical books, even books about programming or testing, but they have no evidence. It's only about their opinion. And if you look carefully as you read them, they don't have any experiments or science or anything beyond just what they have done. And that's also true if you go to a conference and you hear a talk about some piece of agile development or whatever. And if the talk is only about what this person has seen without any evidence, without looking around to see what other people think, as Mary Lynn and I did with our patterns, we had other people look at them. If it's only about this person and his or her very narrow experience, that book, that talk, it could be valuable. All I'm saying is that those are the ones where I feel leery, I'm not sure, I question, I'm uncomfortable, and sometimes they're so simplistic that people walk out thinking, now I have the answer. This is the way to do anything, when really it's just that one person's point of view, just their opinion. Makes me very nervous.
Yeah, and I've noticed a long time ago that the standard of proof in software development is very low. It's almost
Yes.
at the level of opinion. But this is
Yep.
also related
Stories.
This is also related though to one fundamental question which I'm not sure we answered which is, can we actually have scientific proofs, not for programming per se, because there you can have, but for the whole dynamics of teams, organizations in software development, in various projects of various sizes, and
The answer is yes, because that's really what social science is all about. Social psychology is the study of groups, and there are lots of evidence-based results that could apply directly to software development. So if we can't do it, we should look to those domains where they do evidence-based research and apply that to what we do. And that's actually what I try to do now. I know most people don't have the time to wade through either the papers or the technical books, but there's a lot of evidence out there that could help us, but it's difficult to translate. So I'm doing what I can, but the answer is yes, we could be better, and we could, even if we don't do the science ourselves, we could look to others that do.
And I think one of the challenges that we face is that many of these projects that deserve research are in large companies, which are very careful with their secrets. And so a lot of the research is actually closed down inside those companies. You cannot publish a lot of things. So,
yeah, exactly. But if we all did the same thing, which is to look outside to look in the domain of social psychology, there are a lot of evidence-based results there that would help us.
Mm.
Yeah.
Okay, next question. What topic do you think is not discussed enough in our industry or communities?
Well, every community has I'll call it a theme. So I'll pick on the ones I know the best. So the patterns community has a theme of patterns. And what we never talk about in the patterns community is maybe this is a waste of time. No one ever points out the negative side or the arguments against or what are the downsides or where does it fail or it's all oriented. We talked about this at the very beginning, how negative we are. But when we are in these communities, we lean toward being overly optimistic, overly positive, and you rarely, almost never, hear from a good skeptic asking some hard questions. So that's true for patterns. That's true for the Agile community, especially if you go to an Agile conference, you're never going to hear an Agile skeptic. Somebody who's going to ask the hard questions about, well, what should we be thinking about? When does Agile not work? When should we be careful about certain Agile practices in certain domains? Nobody ever talks about that. So it's not just us, through across the board. I was part of the medical community for a while, and if you go to a medical conference, if it's about surgery, it's all about the benefits of surgery. No one, and they don't do experiments, by the way. No one ever said, well, maybe we should not do this particular surgery. Maybe the benefits are not there. They never examine that. So all communities do that. When you get together a bunch of people who are enthusiastic about a topic, there are no skeptics. You don't talk about it.
Guess the kind of an in-group thinking.
Yes, yes.
We feel good supporting each other's struggles
yes, we
sometimes.
like it.
Yeah.
We like it. Yes, we do. Yeah, we all do.
Okay, next question. What topic do you think is discussed too much in the industry?
Well, obviously, it's the benefits. How wonderful patterns are. And we hear testimonies of, oh yes, patterns are the greatest thing that we've ever done. This will save the world. All the problems in the world, any problem you name, we could solve that with a pattern. And we begin to see that, whatever it is, it's almost like being infected with a virus. Once you're infected with the patterns virus, you see everything in terms of patterns. Once you're infected with the Agile virus, you see everything in terms of Agile. You see all the solutions to every problem that comes along in terms of Agile. And that's what it's hype. It's an over enthusiasm about what this thing can do. Surgeons do the same thing in the medical community. Any problem? The answer is surgery. And they're not being deceptive. They believe it. We believe in surgery. We believe in Agile. We believe in patterns. And so we spend so much time emphasizing how great this is. That's what happened at Uppsala, and now Uppsala is gone. So the lesson we should take is things come and go. Uppsala's not here anymore. Nobody talks about the benefits of OO anymore. So that will also happen with Agile, patterns, surgery. Things come and go. If we take a historical perspective, that's what history looks like. Things come and go.
I'm curious here about one thing because it looks to me like software development is particularly prone to fashion. We had the microservices fashion recently, and after a few years,
Yes.
people started realizing, oh, maybe it's not such a great idea all the time, and so on.
No.
Are other domains from science prone to fashion as well, like mathematics, for example, or chemistry, or
Yes, of course they are. It's the difference is that they're further along. I mean, think about how old mathematics is, the oldest of the domains we're talking about, but so is medicine. Medicine is also old, and certainly all of them have had trends. And in the beginning, there was no science. No one was doing experiments. They all were philosophers. So the people who started medicine, if you go back to Hippocrates in ancient Greece, he was a philosopher. And his ideas were not based on doing postmortems on dead bodies. They were based on what he thought about what made health and what made illness, what caused illness, what physicians could do about illness. And at the time, his ideas were popular, and then they were replaced by, in the Middle Ages, there were other ideas that came about. And then those ideas died out, and then others. It's just they've been around for so long that now we don't see them in the same light. Computer science or computer engineering, software development, whatever you want to call it, is a baby. I mean, this is within my lifetime. I started out by saying I didn't start programming until 81 when I was 40. It's a baby science. It has all happened within my lifetime. Medicine is thousands of years old. So it's had more time to become more scientific, not so much prone to hype or fads, but it certainly has them. Even now, it certainly has them. Yes.
so we are still the philosophers of programming, more
Yes,
or
we
less.
are. Yes, we are. Yes, we are.
Okay. So the next question, it's a bit weird to ask you this question since you have a long career with a lot of achievements. I will ask and then we'll see if there's anything around it that you can answer. I like to ask people what would be your ultimate career achievement?
Oh, I don't know. I haven't done it yet. I feel like I am very lucky that I have lived as long as I have and that I have been able to see as many things as I have. And if I have made any contributions, it's because of random luck. That I feel the thing that I have done that has made the most contribution is to look around. Most people look within. So the patterns community looked at patterns. They looked at Alexander. The question I asked was, well, these are fine, but how do you get people to use them? And now I'm going to step outside this domain to do something that I've never done, look at an area where I have no expertise and learn about how you influence people and bring that in. And in the agile world, I started looking outside software development to look at cognitive psychology and animal behavior and the work of Carol Dweck to say, I think that really does help us understand agile better. So maybe if I've done anything, it's to look outside, find things I didn't know, try to make sense out of it, and help people do a better job.
Right, that is very inspiring. The last question, what advice would you give to a younger version of yourself?
So when I was younger, I thought I could see the path ahead. After I graduated from college, I had a degree in chemistry. I married the boy I started dating in high school. I knew that I wanted to go to graduate school. When he finished medical school, I thought I could map out my life. I thought I knew where I was going. I thought I knew what I wanted to do. I thought I had made all the important decisions, and now all I had to do was just do it. And if I could have a conversation with me as a younger person, I would say, you have no idea. You have no idea where you're going to go, what you're going to do. You are going to change so many things along the way. You're going to learn about yourself and about the world. So be open to that. I didn't know the word agile at the time. I said, that's the secret. You have to be agile because it's going to be so different from what you imagine right now.
All right. This is amazing. So, is there anything else that you'd like to share with our audience that we haven't talked about?
Let's close by talking about the pandemic, because we have all been through a horrendous year. We know people who have been very sick. We know people who have died. We know how stressful this has been. And the focus has been for us all so much on the negative because it has been a negative time. But if we imagine what it's like, say a year or two down the road when we return to normal, whatever normal means, there are going to be a lot of good things that will have come out of this experience that we would never have had if we hadn't been in the pandemic. The pandemic has brought benefits that we are having a hard time seeing. The pandemic has a lot of positive aspects that somehow we are blind to right now. All we can see is the pain and the stress, the negativity. So if we would just take a moment to think about all of the good things, because there are many, all of the good things, all of the benefits, because it ain't over yet. We have to hang on. And if we have just a few little positive lights to help us along the way, we'll be able to be more successful. So look for the good things.
Thank you, Linda. Where can people find you?
You can go to my website, lindarising.org. The main thing that's there is a contact email. So just search on Linda Rising, and you can send me some email if you have questions about anything we talked about today. It's been an absolute pleasure. Thank you for inviting me. You all be safe.
Thank you. This was an amazing conversation, and I actually, when I think of Linda, I always think of the amazing Linda Rising. it feels like it's the natural way of saying because I always learn so much. So my what I would advise you is to check out her talks on YouTube. You find a lot of them, and the materials that she published and the books. And perhaps join in a PLoP community meeting is not that hard, and now many of them are remote, so you can actually join easier than before when it was in US or in various parts of the world. We can now join remotely, and the conversations there are high level, very interesting. They will open your mind to things that you did not think about before. I would like to thank you all for watching. We have to pay our dues to the algorithm, so please share, like, subscribe, tell other people about this, comment. The time has passed so fast in this conversation, and I hope for you too. It's been so interesting. And I'd like to thank you all for watching, and until next time, remember to think, design, and work smart.